So next up, we have another team, Akshita, Asad, Max, and Kazim.
Hello, this is Max speaking. I hope you can hear me.
Yes,
All
go
right.
on.
Okay, thank you. I would like to share my screen to show some presentation. Give me 1 second. So here we go. And go for. Can you see it in full screen now? So there's no. Okay, thank you very much. Okay, our project is called Smart Hans, and it's about a mind-reading horse or a mind-reading AI, just to sum it up shortly. Maybe some of you have heard about Clever Hans. It's a horse that you see on this picture, which actually lived 100 years ago. And maybe some of you have heard about the Clever Hans effect in artificial intelligence, which is a phenomenon that describes the core problem of all automated decision making, that you never 100% know for sure on which factors the decision is based on. And this idea we would, and the idea of the crazy idea of this horse and the real story of the horse and this AI phenomenon would like to put into an installation together with our team. And so let's start with the horse. So Clever Hans lived, I think, around 1910 and something. And this horse was really, really curious about numbers and things. Was a very, very clever horse. And the owner of the horse knew about this talent and made a huge profit by touring on fairs and exhibiting the horse and asking people to try out the horse capability to read your mind. And the game goes like this. You have to step in front of the horse and think of any number, maybe not like 2 million or something, because then the next thing that would happen is the horse would look at you closely and the horse would start stomping with its foot until it reaches the number you were thinking of. For example, if you were thinking of 84, the horse would stomp 84 times and then stop at 84 at your number. And the horse did this with an accuracy of about, I don't know, 80% or something. So enough to earn a lot of money with this horse. So how did the horse actually do this? This is the question. So of course the horse could not read minds. What the horse could read was faces and postures. And the horse was just checking for a movement of your head, because the horse knew just in that very moment when the horse would guess your number right, you would make an unconscious movement with your head, a slight jerk upwards about around 1 millimeter measured at the top of the nose. And this is something the horse could see. Nobody knows that you make this movement when the horse guesses right, but the horse for some reason found out, because I think it was rewarded with a lot of carrots for that. And of course, today AI can do this too. And especially if you have a public surveillance everywhere, all you need to do this is you need to have a webcam and this algorithm behind that we're working on right now. So the idea for the final installation, it's quite straightforward. We would have a screen with a horse projected on it with a projector. There would be a small webcam on top and just a post in front telling you that you should wait there until the horse appears, because horses don't like when you go straight head on towards them. And then the horse would invite you to start playing the game by, you would think of a number and the horse would start tapping. So, and what does this installation actually do? It creates triggers by tapping and testing out how you react on this trigger of the horse tapping. And the algorithm, what does it do? It can detect when you do some subconscious reactions and reactions that are abnormal, that you didn't really plan. And then it can generate a certain output towards this. So this is the general idea. And this also shows how you maybe can transfer this algorithm to any other installation where you want to use subconscious reactions of people as a cue for an installation. And it is we are building on an existing proof of concept, a mock-up that we made in another project, in another masterclass built on Python with Wakinator and WebGL to trigger an animation. And we used the PostNet algorithm before, but it was it was not accurate enough. We're looking for a new one right now. And we had some animation made with Blender and animated horse. And this is a mock-up how it was working. Just you could see the horse making the movements, one stomp and the next one. And at some point when the horse thought it saw the head jerk of the person, then the horse would stop. Of course, this is fake. This is just a mock-up to show how it could look in the future. And so the old attempt was working with checking body movement with PostNet. Now we're working, trying to find whether there are better algorithms to do this. The real head PostNet, which is just focusing on head movement and eye movement, and another one which is focusing on facial movement. And the next step would be to create test videos of different people in different light situations and different distances in front of a camera, and check whether these algorithms that we identified so far are capable of identifying the very, very small movement, the irregular movement. And this is actually a picture on the right of Assad testing the first algorithm on his own face. And this is our team: Akshita from India, expert on computer vision; Assad from Pakistan, expert on deep learning; me as the project lead from Germany; and Kazim from Pakistan, also expert on deep learning. So we're quite confident on figuring out this posture recognition part. I think the second part of the project, animating the horse, and the first idea was like to make a real deep fake horse, which doesn't exist so far as I know. It's like this is something that maybe we can get to this, or maybe this is something for a further project. And so thank you very much for your attention, and I'm open to questions now.
Thank you, Max, from our side too. Are there any questions online or here in the room? Yes, come over.
Hi. So overall, I really liked it, the artistic approach specifically. So a very nice installation, I think.
Thank you.
I have a question. Have you thought about making it really concrete in the end? So as the original test was very concrete, so the horse was asked to find out about which number you're thinking, because now it's very general and it's reacting on your gesture or on your micro movements, but to have really a very specific case, not maybe that it's able to find out which number you're thinking of, but maybe something else which is as precise as the original case, or as concrete as the original case.
So at the moment, we try to first just reenact exactly this case that was the historic case of the horse guessing the number right. Once we have figured this out, and once we found this cue and are able to detect it, we can use it for whatever we want. The horse, instead of stomping numbers, it could also stomp to indicate a month, a date, or to indicate nations. And at some point, we would I don't know, I ask a person, what was the last country you visited? And when the horse names this country, it could stop or something. It's totally general.
Okay, so first of all, using the specific case now for exploration and finding out if it's working. But what I would definitely suggest, that if you then found it out after this explorative part, to really make it precise, because in the end this is then the installation, so it can get also a name that is focused on like then on countries or about your thoughts in general, or maybe numbers or something else. But I would really be as concrete as possible and find in the end one case for the installation, maybe find another name also that is dedicated to this one specific thing that you can do in front with a horse. But this is just my individual opinion, but I really love it.
Okay, thank
so
you
I'm
very
curious
much.
to see it somewhere.
Okay, we have two other questions. Mark?
Yeah, hey, I'm Mark. One question: have you ever thought about combining it with an EMG measurement, so to measure the muscle activity, because all these postures are going hand in hand with muscle activity, and maybe it's easier to train the network to correlate these two modalities, and afterwards take the EMG out again, but you have a network which can better respond to the postures. Maybe this would be an idea to get more into this poster recognition. So just a hint, maybe.
So you mean that we need the EMG, just use it for the training, but not not in the final presentation and the final installation.
Right.
Well, I never thought about this, but I don't know how to do this. Maybe my teammates know, but this sounds like a very good idea. Yes, because I think this would make it easier for us to detect that moment. And
I guess so. And I have some contacts to people who do this, so maybe just just contact me on this.
Okay, cool. Thank you.
Okay.
Hi. I think you did a great job showing us the back end. It's a really cool concept. Clever Hans is funny. I love that. I love that. And I see you've got the back end stuff in your modeling pretty well hammered out. So what I think could pull this together is when you finish your model, what are you going to do for the front end? And if you're not going to have a front end, that's fine. How are you going to present this product at the end? Do you have a plan for that?
So one way, and I think the first way to present it would to produce the installation that we showed in the mock-up, like really have a screen with a projector in front, and just a small post, like from a horse meadow or something, that would indicate there's the place to stop and something will happen there. But this was the first case we thought about, just turn it into this art installation. And then from then on, it could be used like not just for exhibitions, but also like totally online with people sitting in front of the screen or something. But the initial idea was to go fully for this installation.
Yeah, that's cool. Yeah, I think it's a good answer. Just the comment would be, you've got a lot of stuff hammered out. You've made some great progress. You've got a complete team. Just give yourself enough time at the end to put together a full presentation at the end. It would be my only feedback.
Okay, thank you.
Thank you all so much. Okay, one last question from Michelle. Michelle, go ahead.
Sorry, I was on mute. Hey, really, thank you for the presentation. Really interesting, the historical context and bringing it back to the modern sense. I think there's also a paper on using computer vision on reading pulse on like your heartbeat. So I feel like we're actually going into like, okay, how do we tell people are exciting? So there's different technology. I think, your heart rate also indicates, that's also another hint. Another point I think it's very important is to disclose privacy issues, because when people step into your exhibit, you're reading a lot of things that people might not be aware of. And I think, for all of us in our realm, it's important to consider just be transparent with people at the same time, whether it's after the exhibit or before, that's totally up to you. But when someone walks into a room, they're being monitored, something to think about. Thanks again for your presentation.
Thank you very much. This is very, very important comment, because I think this has a huge ethical dimension, this project. I mean, the algorithm that we're working on is something that is probably like CIA or eye-border control of Frontex. It is something that they are working on at the moment, if they didn't already have it. So yeah, very, very important. Thank you.
Thank you very much. So I know we're behind our schedule, but as planned, we will make a break of 20 minutes now, so everyone can get some fresh air and get some new concentration for the following presentations.